Hi everyone, so today we're looking at 5.1 using fundamental trig identities. An identity is simply a statement that is true for all values on both sides. So here's an algebraic example of an identity where those two sides are equal. So when we are doing trig expressions, we're going to look for the identities. We're going to change everything to sine and cosine. If we get stuck, we're going to use our algebra. We're going to multiply, factor, cancel. And so we're going to take one side and make it equal the other side using our trig identities. So let's start with example 1. Use the basic identity to simplify the expression. So we use these identities to simplify. So we know 1 minus cosine squared theta. Whenever you see squareds, I want you to think of the Pythagorean identities. Now, one of the most used Pythagorean identity is sine squared plus cosine squared equals 1. Now you can see that this is close, but it's 1 minus cosine squared theta. So how would you get the 1 minus cosine squared theta? You would subtract the cosine squared over to the right-hand side, and that equals sine squared theta. So now what we can do is you can replace 1 minus cosine squared theta with sine squared theta. And then you're going to multiply that by cotangent theta. Cotangent is the same thing as cosine theta over sine theta. And then you can see that the sine thetas are going to cancel with each other, and that's going to leave you just cosine theta sine theta. So another way to write this expression that equals the same thing is sine theta. You don't have to write the cosine theta in front, but I will. Sine theta cosine theta, or cosine theta sine theta. All right, example number 2. So you can see we want to simplify this just like we do in algebra. We're going to FOIL, or basically distribute. So you're going to do first times first, outside, insides, and last times last. So sine x times sine x is sine squared x. And we like to put the square here so that you don't have to use parentheses. So sine squared, and it's not theta, it's x. So sine squared x, and then sine x times 1 is sine x, and negative 1 times sine x is negative sine x, so those cancel. And then last times last, negative 1 times 1 is negative 1. Now we want to look at this identity up here and the Pythagorean identity. If you have sine squared x plus cosine squared x equals 1, you can take this 1 and subtract it over here. So this gives me sine squared x minus 1 equals, now if you want to move this cosine squared over to the other side, then you're going to have to subtract it. So here you would do minus cosine squared x, and then over here minus cosine squared x. So sine squared x minus 1 is equal to negative cosine squared x. So example 2, negative cosine squared x. All right, let me highlight both of those. There's the first one, there's the second one. Okay, let's look at example B, simplify the expression. So you're going to start by multiplying out that numerator. So cosecant times cosecant is cosecant squared x. So we have this equals cosecant squared. Oh, I put cosine. Darn. Cosecant. Try again. Cosecant squared x. And then outside insides cancel. We're multiplying what's called conjugates. And then last times last is 1 times negative 1 is negative 1. And that's going to be over cosine squared x. Now, cosecant squared x minus 1 is a Pythagorean theorem. So 1 plus cotangent squared equals cosecant squared. So that means if you subtract the 1 over, then cosecant squared x is equal to cotangent squared x. So we're going to go ahead and write this as cotangent squared theta over cosine squared theta, or gosh darn, it's x. Now, we know that cotangent is the same thing as cosine squared x over sine squared x. That's what cotangent equals. And then you have divided by, which is the same thing as multiplied by the reciprocal. So multiplied by 1 over cosine squared x. And then, ta-da, you can see your cosine squared x's cancel. This gives me 1 over sine squared, and 1 over sine squared x is equal to, remember, sine loves cosecant. So that would equal cosecant squared x. And so you can see we took this expression, which was rather complicated, and we simplified it to cosecant squared x, which is what it's equal to.